Alexis San Miguel, and I am the group leader for Group 1, and I'll be presenting the Rankine cycle. So for the introduction, the Rankine cycle was developed in 1859 by William Rankine. The Rankine cycle is a theoretical thermodynamic process that characterizes specific heat engines like steam turbines or reciprocating steam engines. It illustrates how mechanical work can be harnessed from a fluid while it undergoes a cycle between a heat source and a heat sink. The objectives of this lab is to understand the operation of a Rankine cycle, as well as measure and calculate important parameters associated with the performance of the Rankine cycle. So the process of the Rankine cycle is that from 1 to 2, the pump elevates the pressure of the condenser, liquid water from the condenser before returning it to the boiler. From 2 to 3, liquid water is emitted into the boiler and undergoes a heating process, transmitting to a superheated state within the boiler's structure. 3 through 4, steam generated in the boiler, characterized by high temperature and pressure, expands through the turbine to perform mechanical work before being released into the condenser at lower pressure. 4 through 1, the low pressure steam discharged from the turbine is condensed into a liquid state within the condenser. These are our diagrams, which are the pressure versus specific volume and the temperature versus entropy, and some characteristics between real and ideal Rankine cycles is that real cycles contain irreversibilities, which include pressure drops due to fluid friction, heat loss, they're not 100% efficient, and also energy loss. Ideal cycles, no heat loss, 100% efficient, no energy loss. For lab safety, wear all your PPE. Safety glasses, long pants, closed-toed shoes. Follow all the instructions from the lab manual. Read it before you do the lab. And also, listen to your lab instructor. Also, make sure that you start and shut down all your devices and equipment properly. For the lab setup, the main components include the boiler, turbine, and condenser, with other components including the computer with the VI, the propane and amp and voltmeter. So some important equations are the energy balance of a pump, which is H2 minus H1, energy balance in the boiler, which is Q3 minus Q2, energy balance of the turbine, which is H3 minus H4, energy balance of the condenser, H4 minus H1. And some other ones. Ideal energy balance, which is heat in minus heat out, minus WT minus WP, which is equal to 0. And finally, your thermal efficiency, which is equal to work of your cycle over the heat added times 100, which is also equal to your entropys. So I did all my sample calculations. I put all my interpolations up here just so that they'd be nice and pretty. So using the saturated water table, and we used the pressure at 276 kPa, and we interpolated the temperature, specific volume, entropy, and enthalpy. Once again, this time we're using the compressed water table, using a different pressure at 758 kilopascals, with our entropy of this process equal to entropy of the one prior. And we can then interpolate the temperature, specific volume, and enthalpy. Wow, we're doing this again. Using the same pressure with x equals 1, we're able to, once again, interpolate temperature, entropy, and enthalpy. Oh my god. So now we're using the same temperature as we used first one, which is 276 kPa, with our temperatures from T4 equal to T1, and our entropy of 4 equal to that of 3, and we calculate our enthalpy through interpolations. And finally, we get to the things that we actually need. So the energy balance of the pump is equal to 5.578 kilojoules over kilograms. The energy balance of a boiler is equal to 2,211 kilojoules over kilograms. We have the energy balance of the turbine equal to 182 kilojoules over kilograms, and the energy balance of the condenser equal to 2,034 kilojoules over kilograms. And we have the ideal energy balance, which the heat in minus heat out is equal to 176, and I put the units. And then I got a thermal efficiency of 7.98, and so I know I messed up somewhere in my calculations. And finally references, yeah.